Well, hello everybody. What I need to do with you today is I need to cover section 7-2. Hopefully your quadratic formula worksheet from the previous class went well. That'll show back up not today, but the following class, the quadratic formula. Let me tell you a little bit about section 7-2. It should be review from your Algebra 2 days. What this section does, there's a lot in here, but a lot of it should be review. We talk about the end behavior of a graph. What we mean by that is what's the right side and the left side of your graph doing. We really don't care about the middle sections. We talk about extrema. So you're going to hear the words today: absolute maximum, absolute minimum, relative maximum, relative minimum. We'll look at the zeros of a graph, aka the x-intercepts. We'll look at where a graph's positive and negative at. This deals with the y values. And then we'll graph one so I can remind you how to find the maximums, the minimums, do a good scale, and then a really, really nice graph. And of course, there'll be an assignment right afterwards. Now, I'm going to start right here. These are not on your notes, but I'm going to treat this video like it's review so it doesn't get to be a 45, 50-minute video. Now, I want to remind you about end behavior. So if you would think about this, what I've done is I've graphed 4 graphs right here. And then on my very next slide, I've got an additional 4. But I want to remind you about some things on the end behavior. I want you to notice this. Notice that all of my a values of these polynomials are positive. Now, what I mean by the a value is once you find your leading coefficient, the highest power, the a value is the constant in front. Notice that all of these a values happen to be 1, but they also have to be positive. Now, when an a value is positive, look at all of the right sides of the graph. Notice that this right side is going up, this right side is going up, this right side is going up, this right side is going up. So one thing I want to put in your memory banks, if your a value is positive, your right side of your graph is going to be going up no matter what. Now the next little thing I want to point out is this. Notice that the even-powered graphs, both of the branches went the same direction. Let me flip to my next screen here for a second. Notice still the even-powered graphs right here. Notice that those branches, the ends, are going the same direction. Now, notice that the odds, one branch is going up, one branch is going down. One branch is going up, one branch is going down. Now, let's put all this together real fast because they're really pretty easy to remember. If your a value is positive, meaning a is greater than 0, the right side of your graph is going to be going up no matter what. Next, look at your power. If your power is even, it's going to match that. If your power is odd, it's going to be the opposite of that. So, what we mean by the end behavior, my a value is 1, my exponent is even, so notice that that side's going up and that side's going up. So we'll say it's going up to the right, up to the left. Since my a value is positive, my right side is automatically going up. As soon as it's odd, the other is going the other way. I'm going to look at my a value. It's positive. That means the right side's automatically going up. Now I'm going to look at my power. It's even, so the left side is also going up. We'll be able to do this without the graph, of course. As soon as I see an odd power, but an even coefficient out front, right side is automatically up. The left side is the opposite since it's odd. If you look at my negatives out here, as soon as I see a negative a value, I know the right-hand side is automatically going down. Now just match the exponents. Even, you match it. I see a negative, so I know the right side's going down. I see an odd, so the left side must be doing the opposite. So, peek at your notes real fast. Look at your number 1 where we say x to the 4th minus x squared plus 5x minus 5. One thing that I want you to notice real fast, there's the leading coefficient. It's positive, the a value is positive, so I know the right side is automatically going up. Since it's even, the left side matches it. We really don't care about the other parts. That gives us the curves in the middle. Peek at your number 2. As soon as I see a positive A value out front, the 3, I know the right side, the right end of the graph is going to be going up. Now let's look at the power. It's odd, so the branches do the opposite thing. If I peek at your number 3, as soon as I see a negative out front, I know the right side will be going down. Now let's look at the power. It's even, so I'm going to match that branch. Number 4, as soon as I see a negative out front, I know the right side's going down. As soon as I see a odd exponent, I know the left end is going up. Now guys, we don't care about what's happening in the middle. I know this graph would be doing something like this. Like I said, this middle part we really don't care about yet. So end behavior should be reviewed from your Algebra 2 days. Now, pop over to number 5. I need to talk to you about absolute extrema and relative extrema. Absolute is really what it sounds like. It's the absolute highest or lowest place on the graph. So for instance, on number 5, the max and min, if you would put the word absolute in front of that, that'll be on every example. So even on number 6 here, we're looking at the absolute maximum and minimum. Well, this is a parabola looking graph. It definitely has a highest point on the graph, but it doesn't have a lowest point on the graph because these branches go down forever. So in terms of an absolute minimum, there is none. In terms of an absolute maximum, it's going to occur right here at point A. Now, it doesn't have a relative minimum because there's no curvatures in the minimum. I'll show you one of those here in just a second. But it does also have a relative maximum, which is also point A. Now, be careful there. Absolute means it is the highest point on the graph or the lowest, but if it's an absolute, it's also a relative. So it gets two names. The number of x-intercepts would be the number of times this thing crosses the x-axis, so in this case 2. Now, number of points of tangency. That means that my graph would just come down, touch the x-axis, and go back up. That's what we mean by points of tangency. So in this case, there are none. The minimum degree of this, since the branches are going the same direction, it's got to be even, and it's got one turning point. Add 1 to that, so this must be a second degree polynomial. That's the minimum it could be. Let's pop over to number 6. Notice that it goes down forever and up forever, so there's no absolute maximums or minimums. Notice that there's no point on here where it quits going up and starts going down or vice versa. So this graph has no relative maximums or minimums. Number of x-intercepts crosses the x-axis just once. Points of tangency, none, because it doesn't touch the x-axis and go back the same direction. The minimum degree of this, well, one thing that I know, it's got to be odd. So it's got to be a 1, 3, 5. Now notice that there is some curvature in here, so it can't be linear, can't be a first degree. So this thing's got to be at least a third degree polynomial because there's some curvature to it. Here goes your number 7. The max and min, once again, we want to talk in terms of absolute max and min. Well, if you look at the absolute minimum, is there a place on the graph that's the lowest that it's ever going to be? And that's going to be down here at point A. So point A is an absolute minimum. That also means it is a relative minimum. Might as well get that out of the way here. Now, let's see if there's an absolute maximum. The answer in this case is no, because notice these branches go up forever. So there is no absolute maximum. So now, let's pick on rest of the relative minimums. That would be low places of the graph for that area. So I would have a relative minimum right here, right there, and right there. I'd have a relative minimum at point A, point C, and point E. That means if we want to talk in terms of the relative maximums then, I would have one at point B and one at point D. So relative just being a max or min in that area. Number of x-intercepts looks like 1, 2, 3, 4, 5, 6. And there's no points of tangency yet, no place where it does that. So no points of tangency. Now to get the minimum degree, since the branches are both going up, I know it's got to be even. Now let's count the number of turning points. There's 1, 2, 3, 4, 5 turning points. We're going to add 1 to that. 6. 6 is even. So the minimum degree of this is a 6th degree polynomial. If we peek at your number 8 real fast, once again, absolute maximums or minimums goes up forever, goes down forever, so there can't be an absolute max or min. Now we're going to see if there's a relative minimum. Looks like a relative minimum right there at point A, a relative maximum then at point B. Number of x-intercepts look like there's 3 of them. Points of tangency, none. Once again, we'll look at number 10 or 9 next. They have tangency on there. Minimum degree, it's got to be odd because one branch is up and one branch is down. And I've got 2 turning points. Add 1 to that, so it's a 3rd degree polynomial at least. Now let me peek on number 9 or number 10. I won't do them both. Let's peek on number 10. Absolute maximums and minimums. Well, notice that this goes up forever. So there's no absolute maximum. But there are some absolute minimums. Now, we're going to name these as ordered pairs. So it looks like I have an absolute minimum right there and right there. So it looks like for sure one of my minimums is the ordered pair 2, 0. Now the other one I'm guessing on. So I'm going to say approximately -3, 0. I just put that approximately in there because I don't know if that's for sure -3, so I guessed. Now, relative minimums then would also be those 2 minimums that we just had. There's no absolute maximum, but there is a relative maximum at that ordered pair right there. So once again, guys, I'm going to guess. I'm going to say that this is going to be approximately 0.5, and it looks like my y value is 4. Now, number of x-intercepts, there's only 2. There's 1, 2. But now, points of tangency, these are referred to as points of tangency. Notice that my graph comes down, touches the x-axis, and goes back up. My graph comes down, touches the x-axis, and goes back up. So this graph has 2 points of tangency. If we look over on number 9, it has 1 point of tangency. Now the minimum degree of this, I know it's got to be even because the branches are both up. And I've got 1, 2, 3 turning points. 3 plus 1 is 4. So there we've got that now. Now I'm going to switch gears on you. So if you would, jump over to your example number 11. What we've done here is I've given you the graph of 1/2 x to the 4th minus 2x cubed plus 3x minus 4. I'm going to review with you what's meant by where is f of x or g of x positive or negative, increasing or decreasing. Now, whenever you see f of x or g of x, you could substitute the letter y. So really part A says, where is my y values positive at? Where are my y values above the x-axis. So to answer this one on this one, where is y values positive at? It's going to be this branch right here that's above the x-axis and this branch right there. So to write that, I'm going to say from negative infinity to point A, always in terms of your x value. And I'm going to say along with point E to infinity. So once again, wherever my y value was above the x-axis, so from negative infinity to point A, and then from point E there up to infinity. So now, where is y negative at? Where's g of x negative at? That's going to mean below the x-axis. Well, where's this graph below the x-axis at? Well, it's below the x-axis from point A all the way to point E. From point A to point E. Don't worry about that. It went down and up, down and up. It was still below the x-axis. Now, increasing is a little bit different. Increasing means where is your graph going uphill at? If this was a roller coaster, where would you be going uphill at? Well, I would be going uphill from here to here. I'd be going uphill there. So I'm increasing from point B to point C, the x values, along with here to there. So along with D to infinity. If you've got increasing figured out, you already got decreasing figured out. Where is my graph going downhill at? Well, from negative infinity to this point right there. So from negative infinity to point B. And then I'm going downhill again from here to there. So along with C to D. Always in terms of the x values. Here in a little bit, if we put ordered pairs with them, you still just want the x values. Now, guys, where I'm going to go next on this is I've already kind of done some grunt work on this one. So the grunt work I've already done, I'll show you here in just a heartbeat. Guys, if you would, I'd like to graph number 12. I'd like to review the graphing calculator with you. We're only going to do number 12. We're not going to do number 13 just because of time, and I think by the time you review part on number 12, you're going to remember number 13. But if you would, graph number 12 there. That x to the 5th plus 2x to the 4th minus x cubed plus x squared minus x minus 4. Now, let me go up and show you that I've got it all in there. And then if you will, after you get that typed in, go ahead and also graph the line y equals 0. That's going to make it easier here in a little bit when we go to find the x-intercepts. Now, of course, let me hit zoom 6 on this so you can kind of see the graph. Notice that there's my graph. What I'd like to do is find everything important on this graph. And what do I mean by everything important? All three of the x-intercepts, this relative maximum right there, and this relative minimum right there. Now guys, if you don't like the way your graph looks, play with your window a little bit, and then you can have more to work with. I'm going to play with mine just a little bit. I'm going to, on my window, I'm going to spread this graph out a little bit. So I'm going to go -5 to 5. And then I'm also going to go from -15 to 15. Just to kind of space that graph out just a little bit. Kind of clean it up a little bit. Now, what we have going here, on part A it says graph it. On part B it said go find the domain. Well, there's no breaks in this graph. So my domain is going to be -infinity to infinity. Now, I'm going to find everything, and then on the next slide I have it written out. So, let's go ahead and just go down there. Determine all local maximum points. So let's go find this point right here. Remember to do that. Second, calculate a maximum. And then they want the left bound, so let's go to the top of the mountaintop, and let's be to the left of that just a little bit. And I got carried away there, didn't I? Hit enter. go to the right, hit enter again. Remember, it'll say guess. We don't want to guess. So there's my estimate. Now guys, on these graphs, we will round to the nearest tenth. So we're going to call this approximately -2 and 10. So wait, since I'm going to round both of these numbers, I'm going to do this. Approximately -2, 10. With the approximately out front, that's my cue. I've rounded both of them. Now the next question said, are any local maximum points an absolute? And in this case, the answer is no, since this branch continues forever. Now let's find the local minimum. So second, calculate a minimum. And then once again, let's go B to the left. And then I'll hit enter on that. Let's go get to the right. Let's hit enter on that. Once again, calculator guess. We don't want that guess, so there we go. Now when I round this, I'm going to call this about 0.4 and -4.2. So since I'm rounding both of them again, about 0.4 and -4.2. Oops. There's a no there, and that really goes there. And then were any of the local minimum points absolute? The answer was no. Now for the range, notice this goes down forever, up forever. So it looks like my range is going to be -infinity to infinity. Now, the x-intercepts. If you think you know them, we can go trace. But otherwise, guys, second, calculate a 0. Nope, second, calculate an intersection since we put in the line y equals 0. Let's go get this one first. So I'm close to it. Enter, enter, enter. So one x-intercept is about 1.1. Second, calculate the intersection. Let's go get the next one. Enter, enter, enter. And it's a nice one, -1, 0. Second, calculate the intersection. Now let's go get the one over there. Get carried away again, Dan. Enter, enter, enter. So it looks like about -2.5 and 0. So now, let me come back to my PowerPoint. Now, so I've got my absolute, I got my relative max and mins listed. I've got my x-intercepts listed. Notice how I wrote those guys. I rounded, so I put the approximately with the x, the part that I rounded. The 0 is not rounded. So about -2.5, -1 was exact, and about 1.1. My y-intercept, that's an easy one to find. That's the constant value, so -10, or -4 in this case. Now, I'm going to graph it, and then we're going to come back and do parts J and K. Now, on this, I noticed that on your assignment sheet, thanks to the Copy Center, your grids didn't come out as nice as mine, so just do your best on this. On your assignment, the grids come out pretty nice, so that's going to be nice. You pick your own scale. In terms of the x values, you've got to cover for me -2, 0.4, -2.5, -1, and 1.1. So on the x values, I'm going to count by ones. So I'm going to go from -5 to 5. Remember, this is your graph. You can count by whatever you want. Now, on the y's, I got to cover at least -2, 10. So there's 5 little tick marks here. So I think I'm going to count by 3s. So I'm going to call this 15 and -15. Now, guys, from here, let's just graph it. I've got a local maximum at approximately -2, 10. So -1, -2, 3, 6, 9, 10. And I'm going to put the ordered pair there for you. So when we talk about increasing and decreasing, you'll see it better. I have a local minimum at 0.4 and -4.2. So about -0.4, maybe right there. 3, 4. So I'm going to put my 0.4 and about -4.2. And I'm going to rewrite that. So I'm going to put my approximate out front. Now I'm going to plot my x-intercepts. I had one at about negative 2.5. So 1, 2.5. I had one at negative 1, 0. And one at about 1.1. That should be enough for us to draw a really nice graph. So here goes. So there's a really nice graph, nice scale, and everything to it. Now, look at my answers where I put where's the function increasing at. Increasing meaning going uphill. So I'm going uphill from negative infinity all the way to this x value of approximately negative 2. So negative infinity to approximately negative 2. And then I'm also going uphill from approximately 0.4, the x value, to infinity. And of course, where am I going downhill at? From approximately negative 2 to approximately 0.4. Now notice how I wrote these. Negative infinity is not rounded. So I put my approximately with the number that I rounded here. But notice over here I put it out front. This is my q that I rounded both. This is my q I only rounded the 1. So guys, that's the graph. When we graph, they're tedious. They take a little bit of time, but sketch it and make a real good graph of it. And of course, there's my graph again. Okay? Hey, I've only got about 5 more minutes of this video. So hang with me on the back. Like I said, we are skipping number 13. I'm not going to take time to do that. But pop over your number 14, or your number 1 here. For the graphs, answer each of the following questions. Is the leading coefficient positive or negative? In this case, look at the right branch. Since it's going down, I know my leading coefficient is negative. And there's my pen trying to help me. I know my leading coefficient is negative. The next question says, is the degree odd or even? Since both of the branches are going the same direction, I know that it must be an even degree polynomial. Part C, is the constant term positive or negative? To figure that up, go find your y-intercept. Go find your y-intercept. My y-intercept is right there, which is positive, so my c value, my constant value, must be positive in this case. The degree must be greater than or equal to what number? So put things together. It's got to be even, and then go count your turning points. I've got 1 turning point, 2, 3, 4, 5. Add 1 to that, and it's going to be at least a 6th degree polynomial. How many distinct roots are there? That means how many x-intercepts do you see? Well, in terms of the x-intercepts, I spy 1, 2, 3, 4. Now, guys, there should be 6 answers, and I've got 4 of them. So now, how many roots have even multiplicity? That means, does the graph come down and touch the x-axis and go back up? Points of tangency. In this case, none. Now, this one's a little trick one. Must there be some imaginary roots? This is an even polynomial. That's key here. It's an even polynomial. It's supposed to have 6 roots, and I only know where 4 of them are. So yes, there must be some imaginary roots in this because it's even. Odds are different, and I'll show you that on my number 2. So on number 2, is the leading coefficient positive or negative? The right side's going up, so it's positive. Is the degree odd or even? Since my branches are different, I know it must be an odd polynomial. Part C, is the constant term positive or negative? Go find your y-intercept. It's above the x-axis, so it must be positive. The degree must be greater than or equal to what number? So put things together. I know it's got to be odd. Now go count your turning points. 1, 2, 3, 4, and add 1 to that. So 5. 5's odd. So this must be at least a fifth degree polynomial. Part E, how many distinct roots are there? There's one right there. Even though it's going to count twice for us, there's one distinct root and then another one. So there's two distinct roots. Really, I know where three of them are because two of them are hiding right here. It got duplicated. Now, how many roots have even multiplicity? One of them. That place right there. Now this one kind of contradicts what I just said. Must there be any imaginary roots? The answer is no. Now, there should be 5 answers. I know where 3 of them are. So I'm missing 2. If it was an even function, there must be imaginary numbers in there. But since it's an odd function, I don't have to have them. I could. I could have 2 imaginary, or I could have none, since it's an odd function. So really, the only time you have to worry about imaginary roots is if it's even. Let me hit my last 1 or 2 with you. If you're good with the video, you can shut it down. So here goes this. Leading coefficient, positive or negative? I know it's positive because the right side's going up. The branches are going the same direction, so I know it must be an even function. The constant term in this case, my y-intercept is right there, so in this case my constant term is 0. Part D, the degree must be greater than or equal to what number? It's got to be even, and there's 1, 2, 3 turning points, so it must be at least a 4th degree polynomial. How many distinct roots are there? There's 1, 2, 3. But be careful. There's really 2 answers right here, 1 here and 1 here, so you know where 4 of the answers are. How many roots have even multiplicity? 1. That's that place right there. Must there be an imaginary? Well, I need 4 answers. I've got 4 answers, so nope. There must not be any imaginary in this case. And then, of course, the last one, the right side's going down, so it's negative. One side's up and one side's down, so it must be odd. The constant term is above the origin, so it must be positive. The degree must be greater than or equal to 1, 2, 3, 4, 5, 6, plus 1 is 7. My part E, how many distinct roots are there? Well, there's 1, 2, 3, 4. Any of them have even multiplicity? Yep, right there. Now, must there be some imaginary roots? As soon as this is an odd function, the answer is no. Could there be? Yes. Must there be? No. So guys, that is day 1 of chapter 7, section 7-2. If you have any questions, get in and see us and we'll get you straightened out. Good luck.